Hello everyone! Today is Monday, June 16th, 9/24. I gotta make this video quick, because yesterday I got no sleep and today it was horrific at work. So either I'm just gonna do like one, or I'll be giving up as fast as possible because, yeah. I'm trying to get to bed like, pretty soon. But let's see. I am curious though, real quick. Summer solstice. Summer solstice is this Friday. That's exciting. So, but I have the longest day of the year this Friday, and that'll kick off the official summer. So technically, we're still in spring, although I'm in the south, so the weather is hot as hell for me. Very hot, very hot. So, already feels like summer. In fact, where I'm from, we already call this summer because it's so darn hot. But anyways, enough of that. Problem 572, subtree of another tree. Given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and nodes and node values of subroot, and false otherwise. This is easy, but it feels like it could be a medium. But so I'm thinking. I mean, how I want to do this. There's also a little error here in the graphic. Thinking how I want to do this is like you'll basically kind of go through, and once you see a character that has the same value as the root, then you'll start the process, and then you can recursively do this multiple times. So if like I'm in the middle of a process and then I see another one, I can start the process again. So let's pull up the same tree problem I did. Actually, no. Let's see if I can just remember how I did it without having to do the same tree. Man, I really need to start speaking on coding. Sorry about that. Just when it's so late, I don't really want to talk. Basically, my thought process is here is that I'm gonna check if the nodes. First of all, you have to check if they're not null, so you can't access the variable value. So if node 1 is null, but node 2 is not, that's an error. If node 1 is not null, but node 2 is null, that's an error, because they're not the same. And the second thing is basically if node 1 is none, then return true. Now, the reason why I'm doing this and not checking node 2 is because by the first statement that already rules out that option. So if node 1 is none here, that means node 2 must also be none. And therefore, we should return true, because none and none is the same. If the value is not the same, we return false. And so then what I'm going to basically do is I'm going to get the recursively recursively grab the similarities from the left side and the right side. I'm going to use the AND statement to basically check. So anytime there's a false, it automatically should break everything. So, oh my days. Yep, so this should check the left side, so it's going to either return true or false. Okay, and I think that, theoretically speaking, works, but probably wasn't. Yeah. For sure. Yeah, that's a silly error, but not a surprising one. I'm guessing probably like 3 or 4 more, knowing my silly self. Hey, okay, we got lucky. Okay, well, not bad. I was doubting myself, but okay. Oh, binary search tree. I haven't touched a BST in a minute. Given a binary search tree, find the lowest common ancestor, a node of 2 nodes in the BS tree. According to the definition of lowest common ancestor on the Wikipedia, lowest common ancestor is defined between 2 nodes, P and Q, as the lowest node T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Man, I have a love-hate relationship with mathematicians because they'll be writing this down. This is the most confusing thing ever when you read it for the first 20 times until it just randomly clicks. Because they write it in a way that is actually really well written. It's just so confusing for every single time you read it until it just works. But hey, that's the name of the game. So, the LCA of nodes 2 and 8 is 6. Wait, what? What are we talking about? I'm so confused. Given a binary search tree, find the lowest common ancestor of 2 given nodes. Oh, okay. So I'm given 2 and I'm given 8. So this one's 2 and 4. 2 and 4, 6. 2. Okay, because it can be a defendant of itself. Okay. That is for sure interesting. Okay, I can for certain see where this becomes a medium. I'm trying to think of how I'm gonna solve this one. So it's not as simple as just check the children's values, because the ancestors can be very deeply buried. Like this one could be like 3 and 9, right? I can give you 3 and 9 here. Lowest common ancestor is 6. So it's like you almost kind of have to like climb back until like you can get back to it. So for certain, the lowest common ancestor can be obviously the root. That's like the lower bound or upper bound or however they say it. For certain, it's the root. As a lower bound or upper bound, because that will always be a common ancestor. It's just questionable if it's the lowest. It'll always be the highest. For certain, 1000%. The root will always be the highest common ancestor, but highest can be the lowest in case of this situation. And then itself also being its own ancestor, which is an interesting concept, but okay. I dig it. Oh, it's giving me the actual note itself. Really? Like, everything and all? Interesting. I'm confused on how I want to do this one. These lead codes are starting to get more challenging on the medium side. So I don't know why auto colored inside. Okay, this is the ugliest binary tree you'll ever see in your life. You're welcome. By yours truly. Because the BST, you can have some weird stuff like this. I love BSTs for that. They're so real for that. Oh, sorry, a burp. So like, let's say it's here, like here. Our lowest common ancestor is going to be here. So how do I find that, right? So first I start here, and then I go like that. And then the way BST works, it goes like left, right, so. So then I'll go down here, so we have 2. Dude, I think I remember doing this in my algorithms class for like some sort of special algorithm. Was it Kosa-Rogers? Or rather, I cannot remember. And this is 3. Okay, so then here we stop. So 2 and 3. So we need to bring these back to the same. Oh, wait, hold on. If they're both true, we just return that. No? Hold on, we could just use trues and false. Let me try that out. What am I returning? I'm returning a tree node. Okay, so I'm gonna return none. If nothing happens. Actually, I'm gonna return root. Root! Because I know for certain root has to be at least one of them. At least one of them. So. I'm curious. This is break. This is gonna like break. Like, what is P? Okay, so that works. Okay, so if it's a parameter, it's automatically hit with a non-local. Who would have known? Okay, so we have to be careful with the P's and the Q's and the whatnots. Oh no, but no, there can only be one. Yeah, there can only be one. So if node equals P or node equals Q, then say result equals true. I hate doing this so much. If there's a coding language where you could like declare a variable inside of if statement and then use it later, oh, that'd be so sick. I know that's like probably like horrific coding practices, and someone probably heard that and their ears on fire listening to that. But my days, I would actually like that a little bit. You know what, maybe not return none. We'll just do... I feel like this is going to be so complicated. False, none. Oh, wait. I'm tripping. So what this is saying is basically, hey, if the children say that there's an ancestor in common, oh, no, can't break. Ah! I wish we could break through out of this. So okay, sorry. If left, basically saying if left and right have seen this child, or the result is one of them, and left or right have had one, then what we're on right now is the LCA. This is so silly. I hate coding like this because it's like it gets so spaghetti. Oh my days, I'm spaghetti all over my code base right now. No, no more spaghetti. No more spaghetti. Okay. See if this silly solution will run. No. Ease it up with that massive printing. Really? What is the dealio here? See, I don't like this. It just feels like it's getting the root. Okay, hold on. So yes, this is false, but this should be true, no? Because this is a true, and false or true equals true. True and true. So false and true is true. So this should be true. What is the issue here? If node.value is equal to 2, print left. Can I do like F strings in here? How do you do F strings? Like that. Oh, dude, why haven't I been doing F strings? I bet all the people watching my videos like been banging their head against the wall. Like, why is this not doing an F string? And to that, I'm sorry. Okay. Huh? What? Please don't do this to me. I'm getting a little confused as to like what's happening here. Oh, brother, I'm so silly. Oh my goodness. I was like, dude, I was gonna start tweaking. I was like, what's going on? Okay. That's probably not gonna work. Yeah. Failed to parse your input. Please check again. What does it mean per se? What is going on here? Okay. What do you mean by failed to parse your input? What does that mean? My input? My input. Failed parsing indicates that the system or program you're interacting with is unable to understand the format or structure of your input. Okay. No matter what, I'm returning a node. Right? You see, you were able to parse it that time. Okay, let me, before I continue going on forever, let me actually just read what his hints are, Mr. Neat. So, yep, that makes sense. Oh, wait, that's smart. My approach is kind of like an O-bend approach, but this approach is basically like, see, my approach is like on a regular on regular binary trade. This is on a BST. So the lowest common ancestor will basically be if the values between those two. Okay, hold on. Let me actually run that, 'cause that's much smarter than what I was trying to do. Oh, hey. This is stupid. um, Python, how to check if a number is in range of numbers. Oh, yeah, right. Bro, I need to get off Python, bro. I'm literally just looking for every single little shortcut I can find. This is getting ridiculous out here. Sorry about that. P and Q. Oh man, nah. This is not gonna work. This is not gonna work because this is. Nope. I can see that going south quickly because if it's the same value, it'll just repeat it and say, "Well, hey, you said equals, so why not?" Nope. No, this doesn't. Oh, this doesn't work. What am I doing, man? This doesn't work. What am I doing? I'm about to give up. Low-key been flopping these past week, but it's just been like I've been getting like no sleep, and it is tiring. I need to finish this up like now so I can go to bed. I'm tired of blue coding. I'm not gonna lie, brother. I'm not gonna lie. Yeah, I'm kind of done with this problem. Yup, I don't really want to do this. I'm What? That makes sense. I'm too tired to be doing this. Alrighty. Sorry about that. Disappointing end, but we're gonna call it there. I think we did 2 today. I am slowing down a lot. A lot. I am sorry about that. But thank you guys for watching, and I'll see y'all tomorrow.